Mon nom c'est Philippe Ozil, je travaille pour Salesforce et je suis développeur advocate. Let me do it in English because I forgot that some of you do not speak French. So, hello everybody, my name is Philippe Ozil. I'm a developer advocate at Salesforce, and it's my great pleasure here today to talk to you about end-to-end testing with UTAM, User Testing Automation Model. So, we're going to have 3 parts here in our presentation today, and I'm going to start with a little introduction of what end-to-end testing is in general, not necessarily in the context of Salesforce. And then I'll talk more about UTAM as a technology, and we'll see some examples of how we can use UTAM to run end-to-end tests within the context of Salesforce development. So let's start with end-to-end testing. A brief refresher on what is end-to-end testing compared to the different types of tests that you can implement in an architecture. This is something I often show when I present this topic. It's called the test pyramid. And when you develop, there are multiple layers of tests that you can implement. At the bottom of these types of tests, there are unit tests. Unit tests represent the simple and smallest component, and it's actually tied to source code. These are so-called white box testing. When you do unit testing, you need to have access to the source code of the things you're testing, and you're testing things at the lowest level, for example, a specific function or a very small amount of code. The higher up you go, the further away you are from the source code. So this is, again, white box testing. You know the source code, you control it, and you can test it. On top of this, you have integration testing. Integration testing is something that is now a bit more complicated because it involves generally more than one system. It involves your own source code, but it also involves a third-party system or many third-party systems. For example, integration testing can be when you try to connect with an external database or when you need to call a web service, for example. And so as soon as you start adding more systems, the tests also become more complicated to set up because you need sandboxes for those external systems as well. And if you are a Salesforce developer here, which of course some of you are, you often do integration testing already in Apex. In Apex, you do both unit testing and integration testing because sometimes in Apex, you also write tests that connect with external systems, like you can simulate a callout or you can simulate even data storage. And that is already to the level where you do integration testing because you're testing things that not only depend on your code, but depend on other systems. Even if it's within your application, it depends on other services like data storage again. So these are the 2 basic levels. And after that, there's a 3rd level, that's the end-to-end testing. End-to-end testing is very different compared to those 2 types of tests because in end-to-end testing, you no longer have access to source code. You don't need to have access to the source code of the application you're testing. And what's interesting with end-to-end testing is that you're actually the closest to the behavior of your end user. You will try to do the same scenario that your end user is doing. That means navigating an application, running a search, typically the behavior of a business user. However, building such tests is way more complicated than writing unit tests. The higher up you go to the pyramid, the more expensive the tests are to write and complex to write. And not only writing them, but also maintaining them. So these kind of tests, end-to-end tests, are generally fragile. It means that these tests heavily depend on the user interface of your application. If you change something in your application, or if a subcomponent of your application changes, there's a risk that you break your end-to-end tests. So typically what will happen is that you have an application and then the software vendor releases another version and maybe they change just a bit of CSS, maybe they change the positioning of some element on the page, and then your end-to-end tests are broken. You need to maintain them, to refactor them so that they now work again with the newest version. And of course, because end-to-end test not only depends on your code, it depends also on third-party code, there's a lot of risk that these tests break. So the best practice here, which is maybe not very easy to understand because it's a pyramid, it's not really a bar, but the best practice is called shift left. Shift left because normally you also visualize the test pyramid in some sort of bar from left to right. So when I say shift left, it's more like shift down, go work more on unit tests rather than end-to-end tests. That doesn't mean end-to-end tests are useless. To the contrary, but again, they're more expensive. So better catch the bugs as low you can because it's the most effective way and it's the easiest to maintain. However, sometimes you do want to write end-to-end tests, and this is where we're going to talk about UTAM. UTAM is going to help us write those end-to-end tests, and also it's going to save our day because it's going to make them way more easy to maintain. So what is UTAM? UTAM stands for UI Testing Automation Model. That's quite of a name. But what is important here is that it's an open source tool that has been built by Salesforce. And not only that, we built the tool, but we are also using it internally. And I think that's really what makes the difference here. Salesforce teams, the product teams, the ones that are building all the Salesforce org, landing experience, stuff like that, they are using it in their day-to-day work. They run their own end-to-end tests with UTAM. So with that power behind it, like hundreds of engineers working with this tool, it has become quite a powerful tool. And the way it works is that UTAM is not an end-to-end test tool on its own. It's a helper for an existing tool. So you can pick your favorite end-to-end test runner, something like Selenium or WebDriver IO, for example, just to name two of them. And then UTAM adds on top of these runners. The advantage is that it makes the code of the end-to-end tests way more robust and way more efficient, because we're going to see that in the next slides. It's going to decouple your test code from the actual content that you're testing. The reason why end-to-end tests break a lot is that they're deeply connected generally with the user interface of the page you're testing. But when you decouple that, the test code and the page, you are going to simplify your life, and this is what UTAM helps us do. So let's see a bit with a little diagram here how this works. On the left here, or sorry, on your right, no, your left, you have a page that you want to test. So it's actually one page, but it can be multiple pages. It's something you have, for example, in a browser. Now, UTAM does work for more than just web pages. It can also be used in mobile, but in this example, we're going to focus on a web page. So you have your page that you need to test. You do not have the source code of this page. You don't need to. And what we're going to do is that you're going to write something called page objects. Page objects are small files written in JSON, and what they do is that they reference certain DOM elements of your page. So for example, if you have a header or if you have buttons, you're going to create some links to certain elements. So you're going to describe the way to get to those elements. Seems easy for the top level elements, but as you go down the hierarchy, it looks more complex. Now the power of UTAM is that it uses composition. So you're not going to write a single page object. You're going to write maybe 10 of them, 20 of them, more, and you're going to compose them so that you have your page hierarchy with a composition of page objects. After that, you're going to use UTAM to turn those JSON page objects into actual test code. And the way it works is that there's something called UTAM compiler, and the UTAM compiler will take your JSON objects and will turn them into code that you can run. Right now, we support UTAM with JavaScript, TypeScript, and Java, so you can write your test code in any language that is in this list. And when you write your end-to-end test, you'll reference those compiled page objects in your test. So that means that your test code here is not directly connected to the page itself. Because there is the JSON page object in the middle, if the test page changes, or if, for example, the header changes, or anything in the page changes, well, you're just going to have to fix the JSON page object, recompile it, and not modify your test code. That is making a huge difference, and we'll see that with an example later. Once you have your test ready, it's the general behavior of a test runner. Your test runner will use your test code, and it will create a browser that it will control programmatically, and it will simulate the end user action by working with your page. So clicking there, reading the text, and etc. If everything goes well, I can show you an example next. So let's see now. Let's talk more about how we can run those end-to-end tests. And I'm going to switch now. I'm going to, actually, no, one more slide. I'm going to show you something. We're going to use one of the sample applications that my team is building. It's called e-bikes. It's a fictitious electric bike manufacturer that sells electric bikes. And we were testing a page called the Product Explorer. Essentially, it's a search with a number of products, and you have a number of actions you can take on those products to view the details of those products. At the top level of the test, we'll have the landing experience. Then in the line experience, you probably know how this works. There are a number of tabs with navigation bar, and there's what we call a flexi page or a Lightning app page. In the Product Explorer is actually a custom Lightning app page. And in this example, it's a page with 3 columns, and in those 3 columns, we have a number of custom Lightning Web components. And the components that are in orange here are the ones that we have implemented ourselves. The other ones, the ones that are below them in blue, are Lightning-based components. So you see already in this test, we only control source code for a small portion of the page. We don't control everything that is above, so we don't have the source code of the Lightning experience, and we don't have the source code of the base components either. But we're going to be able to test the integration of all of that and do the end-to-end tests. Now, to describe a bit the page, on the left you have some filters. So you can search for certain categories of products, you can search for a price range, and you can enter a number of other filters. And depending on what you do on the left, the center region will refresh. The center region is essentially a list of products, and that will adapt to the filters that are being triggered, and there's a little pagination component, so if you have multiple pages, you can navigate around the page of results. And on the right side, it shows you the current user selection. So when you select one of those product tiles, you can open it and you can look at it. And there's even a little button that will take you to the product record page. So this is the theory. This is what we're going to test. We're going to test, you see, 5 different custom components and then a number of base components. And we're going to see how they all work together with a user scenario. So I'm going to step away from the presentation now. And we're going to see that in action. So where is it? Let's see. There we go. This is my Salesforce org. Let me open it here. I will make it a bit bigger so that everyone can see. Oops, not smaller. That's quite big. So this is Emacs, and we're going to look at the Product Explorer. So I want to show you the real thing, and I'm going to do the scenario that we're going to run the test for. So we're looking at the 3-column layout that I just described in the diagram before, the filter slide, the product tiles on the center, and here, for example, we don't have any selections yet. So I'm going to just put in something here, the name of the product, just to filter, and you can see the list is refreshing. So I typed Fuse, which is one of the brands, and when I select it, it's going to open for me the item that I have selected. And I click on the selected item to get to the product record page. Seems pretty simple, right? But again, we don't control all the source code that helps us generate all of those views, so how can we test all of that? The answer is using an end-to-end test. So now I'm going to look at some source code, and I'm going to show you how we can run this scenario. Now I'm looking at VS Code. It's a bit dark here, so I hope that you can see. I'm going to make it a bit bigger, maybe. And in our page, we have a number of custom Lightning Web components. So these here are all the Lightning Web components we have on our page. We're not using all of them in this particular Product Explorer view. For example, we have something like the product tile list, which is the list of products. Now, when you open this custom Lightning Web component, you see 2 subfolders. There's, of course, the code of the component itself, but 2 subfolders here. __ test. These are the unit tests for the Lightning Web component. This is something we write with jest, but this is not what was going to be relevant for this session. And we have the second folder, which is really of interest for us today, UTAM folder. The UTAM folder contains a page object. So this is how you write in JSON a page object. So we're here at a sub-level, so we're really nested in the page. And it works in the following way. First of all, there's an element saying shadow because we're inside a web component. So it tells us that the UTAM object here is for a web component. So we break the shadow down, we can explore the elements of this Lightning Web component. And then we can have a couple of name elements. So for example here, paginator, we just provide a name for it, and we provide a CSS selector for this component. And if you look at the HTML of our component, I should have opened this as well, you're going to see that our web component has a subcomponent here that is the paginator, which is what allows us to change from one page to another. So by creating a handle to this, we can call another page object because you can see this paginator CSS element is mapped to another page object. And if I were to look at my paginator element, custom element, I can look that it has also its own paginator page object. So I'm going to go and open this one because it's very simple to understand. This one just have one single element with the name of the page, with the current number of the page. And we can have some CSS pointers to those elements, and we can also have some methods to calculate things dynamically. So I'm going to show you that with the paginator. It just has one bit of text here, which contains the amount of items on the page, the current page, and number of total items in the search. And you can see here, this is the CSS class that we are referring to in the in the UTAM page object. With this thing here, .navinfo, we're getting this element. This allows us to get a named element, and then we can call a method on it to return its text. So this is just an example of two of those page objects. Of course, in our Product Explorer page, we have, I think, 5 or 6 of them. And by using composition and decoupling those elements, we can assemble an entire test scenario. So now what I'm gonna do is I'm gonna show you how the test runs, and then after that I will show you the test code for running this end-to-end test. Now that we have our different page objects, I need to compile them. So I'm gonna run a number of commands. I need to drop the mic for a second to do that. Alright, so I'm going to run this particular script, test UI compile, and this is going to transform all of my JSON elements into actual JavaScript objects. So remember the paginator element, that page object we have here? Now, by running this script here, I've created a new folder in my project, and it's actually there, page objects here, and this has created for me a JavaScript object that represents this JSON structure, and also a TypeScript version. So you can look at the JavaScript implementation. And this code has been generated based on what I've wrote. And you can see here, getNavInfo was generated from the CSS handle that I just wrote before. So this is pretty simple because paginator is at the lowest level, but as you have higher level components, the complexity will grow and increase. And now that we have our components, we have generated those JavaScript and TypeScript components. We're going to we're going to log in into our org with UTAM, and we're going to run the test. So let me just type another script here. So right now I'm typing another command, which will get me a session ID, and we're going to use it in the next command to process our test. So the last and final script I need to run is just test UI, and normally, if everything goes well, you're going to see a Chrome browser open automatically, and you want to look at what is going on down there. It's going to be a bit fast. You see here it opened automatically my Chrome browser, and it's going to simulate the actions that I just shared with you a second ago. So it's going to look at typing a search in the Product Explorer, and it will display a new list of products. It'll make sure that our products is in this list, and it will select a product, and we're going to the product record page. So here I think it did not work. Sometimes the test just fails. That's because depending on the time it takes for the network to run, it may or may not work. So that's a bit of one of the problems with end-to-end tests, is that to the difference of unit tests, they're sometimes what we call flaky. A test can be correct, but sometimes because of network issues, because the test just crashes, and you need to rerun them a couple of times and just look at statistics. Hopefully this time, yeah, almost. So you can see it went a bit further now. It was able to open the Product Explorer page. I'm going to try to run one more time. And if it doesn't work, I will show you a video because I've captured a test that runs with a video. And it could be that I've tested this with a much better network and it was passing all the time before. So it's not the first time that I try to show it and it doesn't work. So it's not too much of a surprise. But the instructions are there and they're totally valid. So I will show you the video of the test that runs if this last one doesn't work. Yeah. Doesn't work. All right, so I'm just going to show you the video and then I will explain a bit how the code works. All right, so this is the same command that I'm running, test UI, and then this time it opens also the Chrome browser. And on this particular occasion, I had a very good network, and it just passed as I expected it to do. So switching to the Product Explorer tab, typing something in the search results, restricting the amount of items that are displayed in the list. Here you can see I typed fuse, and then it went super fast. We didn't even see the rest of the test, but it clicked on the fuse element and it opened it. So how does it work? Now that we have the code for our UTAM page objects, we can use this code in our test. And this test is here. In the example I'm showing, it's using WebDriver IO, and we're going to see how it works. So it starts with a number of imports, and all of these imports are located in the page object. So these are the compiled page objects that I've created in JSON that are now transformed into JavaScript modules that I can now import. Here you can see I have a timeout and a number of things that are expected, like specific information for pagination. And I'm going to go very quickly now to the test itself. This is our test. So with about a bit more than 50 lines of code, we can test the scenario. First, we wait for the browser to open. Then we get handles to the different elements on the page. So for example, the navigation bar, we navigate to the Product Explorer. We wait for the Product Explorer to refresh and be displayed correctly. We just make sure that all the page is loaded. So this time this is what is causing some issues, because sometimes the page takes a bit too long to load. Then we grab some handles to the different components that are on our page. So left, center, and right. And from those handles, we can get our page objects for the filters, for the tile list, and for the product card. The product card being the selected element. After that, we can check our page. So what we do first is that we test the initial state of our page without even trying to interact with it. We just make sure, for example, that there is no selected item. So this is, for example, showing that all the items are selected. In my test data, I know that there are only 16 items. So when I see in the paginator 16 items available, I know that this is the default data. I make sure that also that there is no selection. So the product card that is on the right side of the page should say select the product to see details. And after that, I'm going to really start to interact with my page. So I start by grabbing a handle to the search input, typing in fuse, waiting for the page to filter results. So what I'm going to do is I'm going to do a wait for pagination update, and I want to wait for this text to be showing 4 items, because I know when I select fuse in the search title, I will have only 4 items. This is because I know my test data that is already in there. This is running on a scratch org, so I know exactly how many records there are. We could test this with larger data sets if we wanted to, but the idea is here to make some assumptions. Then we select the first item on our list of results. So we get the product tile list, we select our tiles, and we click on the first one. Once we select the tile, we wait for the page to refresh and to show the title Fuse X1. This is the first model of the Fuse category that is going to show up. And finally, we click Open Record on the product tile card, and it will show the product page, the product record page for this one. And that's the final step. We're checking that the URL is indeed a product record page with the right ID and format. So with just 50 lines of code, we've been able to navigate in the learning experience. We've been able to look at several interactions between standard components, custom components, and we've been able to run the simple test. Now, I'm just going to go back with a few more slides, and we'll be done. So that's what we've tested today. We've been, I need to accelerate this a bit. There. We saw how to work with learning experience, how to work with our custom components, and also how to interact with the base components that are part of our custom components. Now, what is really cool about UTAM is that it's not necessarily limited to Salesforce. You could test also third-party technologies. Or for example, if you have an application that integrates with components from the App Exchange, you don't have the source code for those components, but you can still test those by writing your own page objects for those components. So just to wrap it up, a couple of things that are important. Remember to shift left. So that's what I shared with you earlier on when I showed the test pyramid. Never neglect unit tests. Of course, unit tests don't really represent directly what the end user is going to do with your page. It's just testing a small bit of code. But again, it's easier to write unit tests. So it's important to write as many as you can, have a good coverage. And only then, once you're done with those, you can focus on end-to-end tests. And if you have to write end-to-end test, well, I highly recommend UTAM, because what's great about UTAM again is that it will help you make more manageable tests. It will reduce the maintenance pain by using something called base page objects. Because that's something actually I completely forgot to talk about. But when we are looking at this page here, I didn't have to write the page objects for Lightning input, for Lightning slider, or any of those base components, even Lightning card. What is good about UTAM is that since the Salesforce teams are using it, they do provide their own base page objects. Sorry, it's a bit hard to say. Base page objects. For everything that is Lightning experience or base Lightning components, Salesforce provides a library of those page objects. So you don't have to worry about the header of Lightning experience changing when you go from one Salesforce release to another. You just have to grab the next version of the base page objects. This is provided by Salesforce Engineering, and you'll be able to have fewer things to maintain in your own test code. Same thing for the base components. So UTAM here is really helpful because part of the complexity of maintaining all the CSS references to those elements that you do not control or handled partially by the Salesforce engineering team. Now, the other thing that is really good about UTAM is that there are a lot of examples out there, and that's going to be my next and final slide. There are a number of resources that can help you get started. We have the e-bikes sample application, which I just shared, but there are a number of other things, and the documentation is very well written, I think. There are really some cool tutorials, easy hello world examples to more advanced features, so it's really easy to get started. That being said, check out these resources. utam.dev is the official website for UTAM. Again, you can use it outside of Salesforce. It's not tightly coupled with Salesforce. So if you wanted to use it, I don't know, to test a React application or something else, you can use UTAM as well. And then there are a number of sample repositories if you want to see some source code. The eBikes project that I just shared is here. That's one of our sample apps, and it does contain the code that I shared and I used today. So hopefully when you're at home, you can make the demo work, unlike what I did here. And there are a number of also other repositories which are built and maintained by the product team. 2 repositories which are containing recipes, UTAM JavaScript recipes and UTAM Java recipes. So if you want to switch from Java to JavaScript, you can use UTAM in the language that you want. You'll be writing the same JSON page objects. The only difference is that they're going to be compiled to different targets, and you can write your end-to-end tests in those languages as you want. And that's it for me. I'm going to be taking questions if you have any. Thank you.
So actually, I have 2 questions. You said that you can use UTAM with any test runner. Is there any, let's say, effort to come with your own test runner and make it work, or is it like out of the box? It's going to work? And also, second thing is that you have some test runners that support, let's say, headless Chrome. Is it going to work also with UTAM, or do you need to have some kind of configurations?
So you're right, these are good questions because that's something I did not explain, but yes. So to answer your first question, we provide by default the driver for WebDriver IO, so there's zero effort when you're using WebDriver IO, but you could also decide to go with Selenium, and then you have a bit of tooling to put in place. I think the WebDriver for UTAM is open source, so you can look at how it was built and adapted to another test runner. To answer your second question, that's also a very good point. In any part, when you run end-to-end tests, you don't always have a server with a screen. So you want to go in what is called headless mode. Headless mode means that you need to open a virtual browser that is not showing up on a screen, but you're still able to run your tests. So yes, this is supported. And in fact, it's totally decoupled from UTAM. It's just your test runner which needs to be configured this way. And if you look at e-bikes, in the configuration of e-bikes, there is a configuration for the headless mode. That's not the one I shared with you today because, of course, it's not visual. You wouldn't see anything. You would just see the console just scroll endlessly. But yes, it's possible. And I tried it. It works well. It allows us to get rid of a bit of lag when you run the thing in CI.
I think my question joins the same topic. So basically, in a process where you can still run it within a pipeline, automate the process, right?
Absolutely. So I can very quickly share it with you if you're interested. What I shared right now was using Chrome, but again, when you do end-to-end testing, you also want to test with multiple devices, and that can be a huge win, because you can test whether your app is compatible with Chrome, with Firefox, or even Internet Explorer. So the example that I shared just today was using Chrome, but you can configure a number of options in your driver configuration. Here, today I've tried with Google Chrome, and you can see if I were to uncomment these options, I could put in headless mode, I can disable the GPU to not compute any graphics, I can play with a specific resolution. You have a lot of options, but these are not directly tied to the use of UTAM. It's tied to the test runner.
The problem you faced when you run the use case, it failed a couple of times. So when you go in headless mode, are we sure that when it runs, if it is successful, it will be successful, or it will have the same problem?
So the thing is, when you run end-to-end tests, there's a lot of things that can go wrong, especially like network. This is generally the biggest problem. You create a new Chrome session, so there's no cache, so you cannot benefit from the speed guarantees of the session. But when your test fails, you have some clear error messages saying, I could not find this CSS selector, I could not run this action. You'll see a reason why the test fails. And you don't want to look at a single test run. Generally, you want to look at maybe 100 test runs. And if you see something that was running all the time and starts failing, this is where you start to look into investigating and what were the causes of error. So to the difference of unit tests, which once it's failing, it will always fail. There's not going to be any magic. This here is a bit more tricky. You want to look at statistics rather than just a single execution. Oh, we're done. Sorry. I can take questions here. So come here and I'll answer questions. Thank you.